Okay, people, we are back. Took a break for 3 days. Catch up on some business stuff. Ooh, that's me. Oops. Forgot to mute the phone, so it played my voice. Okay, today we are doing day 16. So without further ado, let's get into it. Lua. Okay, day 16. Aunt Sue. Your Aunt Sue has given you a wonderful gift, and you would like to send her a thank you card. However, there's a small problem. She signed it from Aunt Sue. You have 500 aunts named Sue. Of course you do. So to avoid sending the card to the wrong person, you need to figure out which Aunt Sue, which you conveniently number 1 to 500 for sanity, gave you the gift. You open the present, and as luck would have it, good old Aunt Sue got you my first crime scene analysis machine. Just what you wanted, or needed, as the case may be. So the my first crime scene analysis machine, MFCSAM for short, can detect a few specific compounds in a given sample, as well as how many distinct kinds of those compounds there are. According to the instructions, these are what MFCSAM can detect: children by human DNA age analysis, cats, it doesn't differentiate individual breeds, several seemingly random breeds of dog, Samoyeds, Pomeranians, Akitas, how do you pronounce this? Vizslas or something. Goldfish, no other kinds of fish, trees, all in one group, cars, presumably by exhaust or gasoline or something, perfumes, which is handy since many of your aunts who wear a few kinds. In fact, many of your aunts who have many of these. You put the wrapping from the gift into MFC SIM, it beeps inquisitively at you a few times and then prints out a message on ticker tape. These: children 3, cats 7, Samoyeds 2, Pomeranians 3, Akitas 0, Vizslas 0, Goldfish 5, trees 3, cars 2, and perfumes 1. You make a list of the things you can remember about each Aunt Sue. Things missing from your list are in 0, you simply don't remember the value. What is the number of the Sue that got you the gift? Right. So this is a matching task. So let's get this in our input, and let's see. Okay, the first thing, we parse it, put it in a table, and then we'll see. Almond milk. Almond milk is the best milk. Okay. So I don't remember how to call it. File was IO open, right? And then input.txt, and then read R for read. And there had to be a local here. Okay. Then I'm gonna go over it line by line, probably. Let me just open it here. Input, right? Yeah, I want to go over it line by line. So that will be for line in file lines, right? Do. Okay. Oops. Excuse me. Let's have a local Sue Aunt Sue. Okay, we'll split it by words, I think, and then we'll take out this word. Okay, so yeah, we'll split it by word and just see. How will you do that? Well, local words is a table. Then I'm gonna see forward in line G match, I believe, if I remember right. And then we have to match every I forget how it works, so I'll just check in the previous example. Yep, this thing. We're gonna do words. We're gonna do table, table append, table push, insert, insert. There you go. Words, word, and there you go. Okay, so now I should have words. Let me just make sure by printing table concat words with, let's say, tab. Why not? Why don't we do that? Oh, and we started at 240, so we finish at 340 probably. Around there. Lua part 1. Yeah, we get, okay. We're getting everything. So this is good. Now, what do you want to do here? Each one of these has exactly three properties, right? So we only know, yeah, we know 3 properties about each one of them. I don't think there's any single one with more. Yeah, okay. So, let's do it like this. Props. And we're gonna say words. It's gonna be 1, 2, and 3, right? Third word. Third word. Well, you know what? We're gonna have to strip the final character here, but fine. Is equal to words, or is it this syntax? I think this syntax. Then 5, then 7, and then 6, and then 8. And yes, these aren't perfect yet, because we definitely have to convert these to numbers. So to do that is just to number, right, and pass this in. Now these two, the first two, have a comma after them, so we will have to get rid of that by saying substring, I believe. Was it substring? Let's check. How was it last time I did it? Sub, and then from first one to the, yeah. What was it? Yeah, it was. So sub from first one until oops, this one, words for -1. Right, so we're just getting rid of the last of the trailing comma for these. I will do the same for words soon too, because we have to do that for words as well. Okay, I'll just move this here just to make sure. Comment this out. Table insert onto props. Right? Okay. Let's actually print this first, just to make sure. So that's gonna be what? It's gonna be, well, props for KV in pairs. Props do. Right, let's just do that and say like print this at the end. And here we're going to say print KV, like so. Yeah, okay, so we're printing stuff. Great. Now, notice that here we still have the trailing semicolons, so we want to get rid of that as well. So the way we do this is going to say the same thing as we did here, except on these. It's going to be 1 until words some number -1, right? 3, 5, and 7. Wow, that is terrible. That is hard to read. I'll clean it up in a moment. But it works now. Yeah, it works. Local strip last. Gonna see that function. That function does what? this function will word. This function will return word sub 1 until the length of word minus 1. Oh, pardon me. And there you go. So now we don't have to do this. You can simply say strip last. Boom. And the same for this. Strip last character, like so. Now it's more readable. And it works. Perfect. Okay, perfect. So this is the input for the ounce. Now this is the input for the MFC SAM output. So let's make that a constant. So local MFC SAM output. I'll just put it in here. So we're gonna say something like oops, no, comma, there you go. Right. So now we know what well, we have the output here. We can try matching. Okay, so let's comment this out. And okay. Okay, so how would you do this? Well, probably by process of elimination, right? In essence, if an aunt could possibly fulfill these requirements, then, well, you know what, I want to make sure that we don't ever get false positives. So let's just iterate over all ounts and make sure that only one of them fulfills the requirements. So how would that work? Well, we'll go over the ounce. So for I and then ount in I pairs. This is how this works. There's 3 values: an iterator function, the table t, and 0, so that the construction will iterate over the key value pairs. Yeah, okay, this makes sense. Yeah, this does make sense. Okay, so let's just put in our ounce su in here. Do and then end. Perfect. Oh, you know what I could have done here? I wonder if this would have like been... So this doesn't really do anything. It's just me who wants to print it nicely. Yeah, it works. So like for this one, this ount, these are true. Yeah. Okay. So let's write a function that will check those. Well, do we need a function here? I didn't think we need a function, so let's just check if the ount qualifies, right? So we're going to go over these properties here for every name and number or amount in pairs. Do an end. So if we don't qualify for one of them, we're just gonna exit this and break out, right? I mean, we're gonna make this a false and then break out. That's what we're going to do. Okay, so How do we know if a key is set in an array in Lua? I guess we just check it if it's null, right? Okay, so if this aunt of this property, so this key, just a prop of this property is not nil, then do, or is nil, maybe, then continue. Oh, we don't have continue, never mind then. It's not nil, then end. There you go. Then we want to check if, well, and this aunt prop is lesser than the amount, right? Then we're gonna say qualifies, whoops, qualifies is false, and break out of here. Okay. Now if qualifies, then end. Gonna say print aunt qualifies. Okay, let's try that. Right, that's not what you wanted exactly. This looks like all of them, like almost all of them qualify. So if aunt property is nil, it's not nil, right? And the property is lesser than amount. Do we have this right? If it's not nil and the property well, I think we should just check if it's not equal, not if it's less. Right. Okay, then only one qualifies, and that makes sense. Let's see. And that is the right answer. Okay, cool, cool. That was the right answer. Great. So that's the part 2. Copy, paste. See, I assume that we may have forgotten how many there are for like particular ounce. How many, like if she had 6 goldfish, and we may have thought, okay, maybe she has 5. But actually no, this is exact. Like all of this is perfect. Perfect memory. Way to go. Okay. Let's see, part 2. As you're about to send the thank you note, something in your MFC-SIM instructions catches your eye. Apparently it has an outdated retrocabulator. And that is a thing. Let's see. Rockwell retrocabulator. Latest technology by Rockwell Automation. This is ancient. Well, anyway. Let's ignore this. So as you're about to send the thank you note, something in the MFC-SIM's instructions catches your eye. Apparently it has an outdated this thing, and so the output from the machine isn't exact values. Actually, I'm a bit curious what this is. I'll watch this later. some of them indicate ranges. In particular, the cats and trees readings indicate that there are greater than that many due to the unpredictable nuclear decay of the cat dender and tree pollen, of course, while the Pomeranians and goldfish readings indicate that there are fewer than that many due to the modial interaction of magnetoreluctancy, whatever that is. How do you even pronounce this? Hold on. Magnetic reluctance. Magnetoreluctancy. Okay. Magnetoreluctance. There you go. Makes sense. Perfect sense. Okay. So what is the number of the real answer? Okay. So in other words, we have to fix our thing here. So this will be roughly the same, except that now we're gonna have to have 2 more ifs, specialized for each, for both cats and for goldfishes, right? Cats and goldfishes. So cats are prop equals trees. Cats and trees, right? Yeah, cats and trees. Then, right? Else if prop equals Pomeranians or prop equals goldfish, then, right? And then else if. Okay. So in here we're gonna say if out prop. So in particular, the cats and trees readings indicate that there are greater than that many due to the unpredictable nuclear decay, blah blah blah, whatever. Okay, so there's gonna be greater than. Okay, so I'm not sure if this is gonna be greater than or lesser than or something else. However, we're just going to test it out, I think, and that should be fine. Qualifies false. Break. Oh no, hold on. Less than or equal. Yeah, that's what it's gonna be. And here it's the opposite, right? There's fewer than, so there's gonna be greater or equal. Okay. So if you run part 2 now, we get 260, and then if we run before, we get 373. Okay, let's see. Let's check 260. It was the right answer. Okay, great. So we've got day 16 completed. I'll put this code in GitHub. Commit day 16. You can get the link to that in the description if you're curious about it. If you want to have a look. If not, that's fine too. I think I'll finish the stream today because I still have a lot of things to do. So we'll just do one add-in code day per day, but like real day actually. I think. I thought they were going to get harder as we are approaching top of the Christmas tree, but apparently not. That's fine. Yeah. Peace. I will see you tomorrow in that case. Oh, and the outro, of course, which is like if you liked the video. If you didn't like it, then I don't know why you're still here. And I botched it, didn't I? Well, anyway. See you tomorrow. Bye bye.